few seconds. Welcome to the webinar, Effectively Using Lean to Streamline Processes. I'm George Spalding, Executive VP. This is also a quick sound check to make sure that everyone can hear me. If you would go into the chat function and just send me a quick note that says you can hear me, that would be great. I'd appreciate that. As soon as I'm loud enough, I can hear you, says Cheyenne, and hopefully I'm loud enough and clear enough. I hope that works. Okay, all right, let's get rolling. We've only got an hour, and that's tops. And maybe we should end before then because we only have, so much attention. How long can you listen to me after all? Okay, so let's get going. So first of all, just to take a look quick at the title, Using Lean to Streamline Processes. Does Lean provide the processes? Not really. Lean does not really provide the processes. So in other words, it can streamline any process, technically, as long as the process is laid out, and we'll get into that later. But basically, it's not about which process you use. It's about making the processes much more efficient, streamlining them, making them quicker. That's some of the key elements. And we're going to talk about depending on your experience with Lean, lots of new stuff, but that'll be okay. We only have an hour, so there's a lot more, and we could go a lot deeper, but of course we don't have time. So let's keep going. All right. So where did this all come from? Well, it starts all the way back in the 19th century, somewhere around the mid-19th century, where the first steam power came into being. So that's actually the beginning of the whole mechanization and industrial revolution, etc. Before that time, the concept of work had been an artisan-like enterprise. Basically, there were experts. You were good at being a blacksmith. You were good at being a mason. You were good at being a carpenter. And in order to train other people in what you did, you would bring them on as an apprentice, a journeyman. And that was the culture all the way for thousands of years, really. Now, a couple of aberrations in there, of course. We built the pyramids, and nobody quite understands how we did that. And then we also built cathedrals, and that was remarkable and amazing for the time because everything else at that point was really just a one-story building. So suddenly we had these gigantic, enormous things. Now, it took, in some cases, over 100 years to build a cathedral, but it was still amazing considering the technology or the lack of technology that they had. Okay, moving fast forward, now we have steam power. So as soon as we have steam power, that simply means that we boil water, comes out, it turns something, it turns a shaft. So when it turns a shaft on a boat, it becomes a steamboat, the propeller is driven by steam. When it turns a shaft on a train, it becomes a steam engine, and it pulls the train across the country. Then we very quickly modify this to turn a shaft that then has belts on it, and the belts then power all sorts of machines in a factory. Now, this is a new concept. We never had factories. We never had factories before this. So suddenly we now have factories. Now that we have factories, that means we have not one or two people, not an expert, an apprentice, a journeyman. No, we have hundreds of people all working toward the same end to produce the same product. This is a new concept. So we start, and so Frederick Taylor starts to get into this and looks at it and says, whoa, this is different. The definition of work has changed. So now we're taking work and we're dividing it into smaller and smaller and smaller units, and people are becoming expert on just their little unit of work and then passing it on, and then we move into the production line. So Frederick Taylor was the beginning of scientific management, becoming an efficiency expert, looking at time and productivity. That was the beginning of that. So now we skip to the very first decade of the 20th century and Henry Ford. And of course, Henry Ford is basically attributed with the concept of inventing the production line. And that's fine. So in the beginning, 1907, what Henry Ford wanted to do, he wanted to make cars that everyone could afford. In order to do that, he had to make cars that were relatively inexpensive. So he had to wring out costs out of that, the creation of that car by making it more and more and more and more efficient. Well, in 1907, when he built his first Model T, it took 14 hours from the beginning of building the car until the car rolled off and actually drove off. The end of the line was 14 hours. By 1914, by a series of endless small tweaks and improvements, it took 90 minutes to build a car from the beginning of the line all the way until it drove off the line. And a new car drove off the end of the production line every 3 minutes in 1914. Now, that's more than 100 years ago. That's unbelievable. It's remarkable that this kind of stuff could happen even then. Now, so from just looking at history, I'm awestruck when I think of what Henry Ford was able to do. When I look at it from my current lean perspective, I think that Henry Ford was a one-trick pony. What I mean by that is that Henry Ford could only take cars off the line every 3 minutes. He wasn't really responding to customer demand. He was just making cars as fast as he could. If you build it, they will come. Whereas in today's environment, and in a true lean shop, we would wait for the order and then we build the car. Because we wouldn't want any inventory up front. We wouldn't want all this inventory sitting around of car parts that we weren't going to need. And we wouldn't want inventory on the back end of a bunch of cars that we'd already built sitting in the parking lot waiting for someone to buy them. Because inventory is considered waste. And when we start talking about lean IT, inventory would be changes sitting before they enter the change process, incidents sitting there before they enter the incident process, problems, projects. All these things can become inventory when we start thinking in a lean way. We'll get there. All right, so let's move forward now into a guy named W. Edwards Deming. And if you've ever taken almost any management or leadership or IDLE class, you've heard of Dr. Deming. And Dr. Deming had a cycle, and the cycle was Plan, Do, Check, Act, PDCA. And he was a mathematician, basically. And in the 30s, he became fairly famous, 1930s, he became fairly famous for understanding and starting to dabble with process improvement. And just as he was hitting his stride, he was yanked away from that and pulled into the war effort in 1940 and started doing all sorts of mathematical calculations for the war effort, so he kind of had to step away from that. End of the war, war ends in 1945. Now he comes back into this in the late 40s. Well, Dr. Deming was notable enough that in 1951, General Douglas MacArthur was basically the emperor of Japan for all intents and purposes. He was running Japan, rebuilding Japan. So they started making the Japanese census. He called on W. Edwards Deming to come over and help with the census because he had actually helped with the 1940 U.S. census, so therefore he would be a good guy. Well, when the Japanese manufacturing grew, now remember to think about what Japan was like at the end of the war. We'd done nothing but bomb all their manufacturing capability. So therefore, the concept of manufacturing in Japan in the 1950s was pretty tough. They were definitely in a rebuilding mode. The amount of resources was very small. They couldn't afford any kind of waste. They really had to slim it down to make sense out of it. Well, here comes Dr. Deming, which is at that time kind of the god of process improvement, process efficiency. The Japanese manufacturer said, since you're coming anyway, would you speak to us about all this process improvement stuff? He agreed, he did. But the fun part was, because he was going to be there for a while, they went back to the factory and implemented it right now. This wasn't a let me jot that down and go later. No, they went and did it right now. So then they would come back and say, hey, it worked. Hey, this worked. Hey, that worked. So that was the way that Dr. Deming, and by the way, they still to this day give away the Deming Prize for Quality in Japan, even though in the U.S. maybe we're not so hip to that. Okay, then we move forward into the world of Toyota and what became the Toyota production system. Originally it was called just-in-time manufacturing or just-in-time production. It became the Toyota production system, not because of Toyota people named it that way, but basically a consultant named it in the 1980s. But basically that's what today's lean is based on, the Toyota production system. So as we go through this, you'll begin to understand more about that. Then we move into the 1980s, 1990s, and Jack Welch at GE adopted what's called Six Sigma. Now, Six Sigma was invented basically at Motorola, and it was invented in the early 1980s when it turned out a lot of these methodologies and frameworks and things like that got their start in the 1980s. When you look back, ITIL, CMM, COBIT, all of these things kind of got their start because it became obvious that, at least in the IT world and certainly in the management world, we needed a way to improve, or we needed a way to measure, et cetera. So when did Lean finally make it into the service end of things, which of course IT is a service? So when did Lean get there? Well, it's actually around the turn of the century. And the first organizations to adopt Lean in a service vernacular was healthcare. Not healthcare IT, but the healthcare clinical side. Because it turns out during the 90s that even in the U.S., healthcare had discovered that there were enormous numbers of mistakes being made, and mistakes that resulted in injury and indeed death. So anything they could do to improve the accuracy and error proofing, that was what they were going to do. And if any of you have ever been to a hospital recently, every single new human being who walks into a treatment room or a hospital room asks you your name, scans the little bracelet they have with the barcode on you, asks you your birthday, so that they can always basically demonstrate that they're dealing with the right person. It's just the most rudimentary form of error checking. Okay, let's keep going. Oh, there we go. Okay, so the Toyota production system originally just in time. It was built on the approach of the founder of Toyota, Sakichi Toyota. By the way, the spelling is correct on this slide. So why did the D become a T? I'll let you Google that and try and figure it out. Anyway, his son, Kichiro Toyota, and his chief engineer, Taiichi Ono, created this concept of just in time. It turned out that the way this happened, the Toyota production system, first of all, started as a quality system. Because what happened was his son said in the 1920s to the old man, said, hey, I know that you started off building looms, which is what they started off building, and actually automating the loom process and even automating the concept of air proofing and air checking in the looms. Because what would happen is the loom would break, the thread would break when they were making the fabric. So they said, well, we have to figure out a way to stop the loom when the thread breaks. So he invented basically this automated concept. When the thread broke, the loom stopped, and he would stop wasting fabric that way. Anyway, his son said, hey, let's build cars. So he said to his son, okay, you are in charge of the motors. You're in charge of the engines for the cars. Well, the son went off and contracted somebody to make engines. Well, it turned out that every engine block that showed up wasn't the same. It was different every time. It required lots of rework, lots of tweaking, lots of drilling, and a lot of extra work and time and money. So he said, boy, if we could get the guy providing me with these engine blocks to give me a high-quality engine block and I wouldn't have to work on it after I got it, that would really save us a huge amount of money. So thus began the concept of the quality initiatives in the Toyota world. The just-in-time came about when the engineer Taiichi Ono visited the United States. And in the United States, he went to a supermarket, which they didn't have any of those in Japan at the time. There were markets and marketplaces, but no supermarkets. And the supermarket was really kind of an invention of the 1950s. So suddenly we have this supermarket. He goes to the supermarket and he watches all these shoppers, for the most part, housewives in the 1950s, and they'd go to a spot and they would take a gallon of milk, put it in their cart and move on. And the next one would come and take a gallon of milk and put it in their cart and move on. And this went on for like half an hour, and he realized that there was no way that there could be that many gallons of milk sitting on the shelf that he watched come off the shelf. So he investigated more, and he realized that he looked inside, and there was a guy on the inside who was putting the milk on the shelf and letting it slide down just as someone would take it off, just in time. He said, wow, we could do that with manufacturing. If we didn't have the bumpers for the cars or the trucks, or we didn't have whatever it was, just until we needed them, then that would be a great thing. That would be a little more efficient. It would be a better use of cash, better use of resources, less space would be required. All of that made total sense to him instantly just from watching milk being taken off the shelf. The Toyota principles are two. Continuous improvement, never stop. Never stop improving. Just constantly look for improvements. Now, there's no question that if you adopt lean and then start it, you're going to have a significant improvement in the first year. There'll be less improvement year 2, less year 3, etc. Because you're going to get rid of the easy stuff. You're going to cherry pick. You're going to take the low-hanging fruit, whatever metaphor we need. But basically, when we get rid of those, then it's going to be a little harder to improve. But the basic principle is just keep improving. Never stop. We're going after perfection. We may never reach it, but we're going after that. And the second is respect for people. And that you're going to understand why that's so important in a few minutes when you see that we're going to be trying to watch the people and watch how they do their work and then try and improve it for them and make it easier and better and more efficient. But in that watching phase, the people have to trust that you're not trying to eliminate their job. You're not trying to force them to go faster. They have to trust you. So therefore, there has to be a mutual respect for individuals. So here's the lean house, we often call it, or the lean Parthenon. But basically, it says that lean is a new way of thinking and acting. It's not a technology. It's a different way to think and act. And it's not focused, not specific to IT, but it works very well with IT if you kind of open your mind and say, oh, yeah, that is kind of the way we run IT. So, number one, the first thing we're looking for is customer value. The customer, we're looking, whatever we do needs to be focused on customer value. Anything we're doing that isn't focused on customer value is considered wasteful. We want to eliminate waste. And we have a lot of it in the world of IT. We have a lot of it in the world of processes and manufacturing. There's a lot of it. Management has to become a facilitator as opposed to the font of all knowledge. So the manager doesn't have all the answers. The manager facilitates discussions and maybe asks the right questions. That's what management does. All the employees are involved. They're involved in the actual do phase of actually doing things, but they're also involved in the improvement phase and anything that we can do to make it better. Why not? They're the people that they're the closest to it. They should obviously be the ones that are involved. It makes total sense. And then a principle of continual improvement. So let's just pick some of these words over on the left. So just in time, we talked about that with the milk cartons. Just in time basically says that we will not have whether it's inventory or we won't pass on or hand off something to the next point in line until that person is ready. So it's going to show up just in time. And that's also going to be called pull. So pull is the concept where if I am at a workstation and I am working on something, shoving the next one to me before I'm ready doesn't solve the problem. It doesn't help. All I'm going to do is continue to work on the one that I'm on, and that one's just going to sit there. So the idea simply is when I'm finished and I pass mine on, I'll take the next one in line, and that's pull. What we were trying to achieve, and this is the hard part, we're trying to achieve flow. Flow means that everything is running basically at the same speed. Every step of the process is running at the same speed, so things just keep moving through the line. And that's the perfect way to build cars, and it's the perfect way to do IT. So that's our goal, is flow. It's very difficult to achieve because obviously each step in the process is different. Some are more complex, some are easier, and that needs to be smoothed out over time. Hajunka is that concept of attempting to smooth out the flow and to get rid of the peaks and valleys of customer demand, because the smoother the flow is, the more efficient the process is, the better off everyone is in there. Let's jump over to the other side. Jidoka. It's called first time right. Let's do it right the first time. Let's stop the principle in IT, which is we seem to never have time to do it right, but we always have time to do it over. That doesn't make any sense. It's never made any sense to me. It's never made any sense to you. just because we somehow have a ship date and we have to meet the ship date to then ship a bad product and then have to yank it or have to go in and do heroic effort to fix it after the fact makes no sense. Let's do it right the first time, and quality then becomes the way to achieve customer value. Right first time. Pokioke is a Japanese word for error checking or error proofing. So the concept here is that it's really simple. Let's just take your USB plug in your laptop. When you put in the USB plug, can you put it in upside down, even though you try all the time? No, you can't. You have to put it in right side up. Can you plug in your phone jack upside down? Nope, you got to put it in right side up. Your network cable got to be, RJ45 got to be right side up. So these are, can you plug in the wall with, can you miss the plugs in the wall? No, you can only plug it in one way, your electricity. So the point here is that that's the hardware solution to error proofing. Now, what happens in our world? Well, most of you, of course, have flown on planes. And what you've watched, of course, is that if you sat anywhere near the front, you've seen the pilot and the co-pilot go over the checklist. And they go over the same checklist for that plane and for those kinds of flights every time. Every time? Every time. Every flight. Every flight. They never don't go over it. Nope, they go over it every time. And why? Because people's lives are at stake. So they have a checklist. It is absolute that they go over this checklist and that they complete the checklist before they start the plane and back out of that gate. Period. End of sentence. That's the way it goes. If it makes them late, it makes them late. The checklist becomes the ultimate error checking and error proofing technology. Well, we can have checklists. We need that. So the concept of standard working means what's the time estimate for how long it's going to take to build a car? What's the time estimate for how long it's going to take to complete a change? What's the time estimate how long it's going to take to resolve an incident? What is the estimate? What's our standard working time? That's what standard working is. We should have an idea of how long things take. Sometimes we don't, because, and we keep saying that famous line from IT, well, you know, everything's different, it all depends. Yeah, well, that's great. But really, it all depends on what, and what's a standard? Okay, it depends on whether it's standard or not. Okay, what's standard? Define something. Come up with a standard change, standard type of change, and well, how long do you think it'll take? Those kinds of things are things that we don't seem to work on well in IT. Visual management is one of the key elements of Lean and Kanban in general, and it's also one of the key elements of DevOps. As we move forward, we don't have time to talk about that element today, but it is the concept of the Kanban board. Okay, Kaizen is the focus on improvement, where we take a concept of either a Kaizen mindset, which basically says always looking for improvements, always looking for improvement opportunities, no matter how small. If there's a piece of paper, it's on the floor, even though it's not your job to pick up pieces of paper from the floor, you pick it up. Our friend Kurt Wiesler has written a great book called The Dog Poop Initiative. Same concept of the Kaizen mindset. And there's also the Kaizen event. Now we say we have an issue, we have a problem, we're trying to make this service more efficient, whatever, and we have identified a very specific area or error, either one, that needs improvement and needs to be focused on an improvement. So in the Kaizen event, you basically draw some nice boundaries so that we can scope the Kaizen event very well, and then we go in and we fix that one thing, get it fixed right, and never see it again. And that's what a Kaizen event is. It's always working towards perfection, always working towards improvement. Okay. The value stream and a value stream map. Now, because I don't have lots of time, I'm kind of jumping ahead. So the value stream is what you and I call a process. A process, as we, how to solve an incident, how to do a change. Those kinds of things are processes, and they came about whether you use ITIL or not. ITIL certainly made recommendations on how to set up an incident management process, how to set up a change management process. So in the words of Lean, that change management process is a value stream. It's a process which by its nature is designed to produce value for the customer. That's basically what that process is designed to do. So it's a value stream, a stream of different elements and different parts, different pieces. Okay, so now let's look at the key elements here of lean. At the center, at the core, is customer value. The definition of customer value is pretty simple. It's what does the customer value? Okay, George, come on. What will the customer pay for? What does the customer consider valuable? Now, there are things the customer considers valuable. They can see that that's work effort. They can see that they need to pay for that work effort. That's great. We call that value-added activity. Sometimes the customer looks at something and says, well, I shouldn't have to pay for that. But we inside IT know it's necessary. We have staffing costs. We have training costs of our staff. We have finance and accounting. We do all of that. And lean refers to that as necessary non-value add. The customer doesn't see that as something they should pay for, but we know it has to be done. And then there's all the other things that we do that aren't necessary non-value add, that aren't value-added activity, and that's called waste. And we'll get more into that in a minute. Okay, we talked a little bit about flow, and the concept of flow, which is making the ideal scenario, which is things keep moving through the process. The ideal scenario is things keep moving at the same pace, so that no one is waiting and there is no wait time between steps. That's the ideal scenario. That's nirvana. That's utopia. That's flow. Pull. So let's look at our everyday life and examples of pull. You go to the bank, and instead of going to the machine and leaving, you have to get in the line to go talk to a bank teller. And there's usually a rope and stanchion type thing, and the next available teller will say, okay, next. That's pull. Same thing at the airport, right? When you go and you get in line, and you're going up to the counter. You know, you're in line, and so there isn't 5 lines. There's 1 line in a rope and stanchion, and then they take the next available. You get the next available person, service agent. That's pull. You go to a McDonald's drive-through, or if you're in Canada, you go to a Tim Hortons drive-through. Either way, it's pull. You go, you drive, you stand in line, you get to the order thing, you order, then finally you get taken, and when you get there, you pay your money and you receive your order. It's pull. Okay? You can't push in that system. Push, if you've ever seen the wonderful video of Lucy and Ethel in I Love Lucy, this is going back 50 years, where Lucy and Ethel decide to go to work because their husbands are just saying basically they can't work. And they decide to go to work and earn money. So they go to the candy factory, and they finally get a job wrapping little caramels into the paper that you have to wrap caramels in. Seems like an easy enough task. So the caramels come along on the belt. They pick up the caramel, they wrap it on the paper, they put it down like it's good. Finally, they've done their training, and the supervisor comes in and says, okay, let's bring it up to full speed. So now the caramels are coming in there. They can't possibly wrap them as fast as they can. Lucy is wrapping them. She's stuffing them in her mouth. She's stuffing them down her dress. She's putting them anywhere she can because they're being pushed. Just like in our world, where we just have incident upon incident upon incident, and it just comes in, they come in. There's no concept of capacity. Pull basically says, look, kids, IT can only do so much. There is a certain capacity as to how many incidents we can handle. Obviously, we're going to prioritize the incidents, but even in a priority setup, we still have only so many that we can go into what we call a lean work in process. So given that we only have so much we can do, that's called capacity. Therefore, when I'm finished with the one I'm working on, I will go get the next one. Lining up 20 of them doesn't solve the problem. Either getting more capacity or pushing them in there doesn't work. It doesn't solve anything. It doesn't fix anything. Same thing with changes. Same thing with projects. It's exactly the concept. And finally, perfection. We are, in a lean environment, striving for perfection. We want perfection. We'll never receive it. But the important part is that we never, ever stop looking for ways to improve. I think, especially in the U.S. today, I really believe that we really have the concept of good enough, that we approach work in a concept of good enough, and that we never get this concept of perfection or always striving to improve. Because if we can strive to improve, things will get more efficient, errors will be removed from the system. So one of the concepts in Lean is that IT incidents are considered waste. Solving IT incidents are considered waste. Solving incidents? What are you talking about? Of course I'm supposed to solve incidents. Well, yeah, you're supposed to solve them, but you're not supposed to have them. It's better if you just don't have any incidents. Do you think that would be a better solution? Sure it would. Okay, so I just talked about these three types of activities: value add, necessary non-value add, and totally non-value add or waste. And our goal is to eliminate waste, redundant work, rework, mistakes, eliminate incidents, and eliminate doing more than required. We do that in IT all the time. We try and minimize the amount of necessary non-value add and maximize the amount of value add activity that we do. So what's some of these examples of waste? Well, transportation. Things have to move between steps. Inventory, just having lots of things just sitting there. They're not in use, they're not in process, they're just sitting. And they're sitting between steps. Just inventory of bumpers, inventory of incidents, inventory of changes. It just doesn't, it basically is wasteful. Motion, too much movement. I have to go to him, he has to approve it, and then it goes back over here, and then it goes back over there, and then it goes to there. You know what I'm talking about when motion. When I say waste, it is wasteful. Waiting time, just what it sounds like. I simply have to wait between steps. Way too long. It's amazing what we do. Over-processing, overdoing it, defects and rework, simply making mistakes and having to fix them. Overproduction, I make too much or too many. And then non-utilized talent. I have very smart people, but I don't have anything for them to do in their area of expertise, so I use them in a much lesser capacity. Variability is that up and down variance, if you will, of customer demand. So I've got high demand, low demand, high demand, low demand. Well, that can be very wasteful in anybody's IT department and in any kind of a manufacturing setting. So what we keep trying to do is smooth that out. Our goal is to get that into as close to a straight line as we possibly can. And down, finally, then, inflexibility and overburdening. Overburdening is what we do in IT. We load you up with incidents and say, hit it. We load you up with changes and say, hit it. We load you up with far too many projects and say, go. You're the expert, take it. Right? The team can't scale up. The team can't add capacity. So the team starts to get messed up. They start to get fried. They start to burn out. That's overburdening. And the other piece of this is what I call inflexibility, or the worst kind, policy enforced waste. It is the policy of the organization to be wasteful. Now, of course, no one would ever say that. But when you actually look at the policy and then look at the steps in the process that the policy is making us follow, especially in terms of approvals and especially in terms of checking and rework and going backwards, it ends up being policy enforced waste. 7 approvals to get something. It's crazy. Nobody ever believed at some point in the past there were 7 approvals, but there was, a new approval was put in to cover this mistake. A new approval was put in to cover that one, and suddenly we have 7 approvals for a $2,000 expense. This is nuts. This is policy enforced waste and has to be removed. Okay, we talked a little bit about push and pull. So, can push work? It can, if there are things that are stock, if not everything is customized, if there's these standardized, like for instance, standardized incidents that come in, resetting someone's passwords, those kinds of things, those don't need to really be dealt with in a pull environment. If things are standardized and those kinds of, if the change is I'm updating the virus signature, we have a nice way to do that, that can be a push kind of environment. Otherwise, it becomes pull. Pull is more is more efficient for anything that's customized, anything that requires individual attention. There's no question that pull makes sense. So here's a definition of Lean IT. It is the extension of Lean manufacturing and Lean services principles to the development and management of information technology products and services. Its central concern, applied in the context of IT, is the elimination of waste, where waste is work that adds no value to a product or service. I think that's an excellent definition in the world of Lean IT. Okay, now I'm going to drill down a little bit, and I know you're going to get freaked out because I'm introducing all sorts of new words. And that's okay, we're not going to cover all of these, but we need it for the exercise that I have in mind for you. And, wait a minute, George, this is a webinar. You're going to have an exercise. Yes, I'm having an exercise. Okay. Cycle time is the amount of time from the beginning, specific time that we begin to work on the process until we are finished with the process. Okay, that's cycle time. Lead time is the time between the very first time the customer either orders something or asks for something, calls about an incident. That's the beginning. That's the beginning of lead time until the actual change or incident has been resolved and is in production at the customer's site. So the change, so if the beginning of it's entered on the change calendar as request for change. That's the beginning of lead time, and then that change is put into production at the end. That's the end of lead time. In the middle, there was cycle time, which is how much time we spent working on it from the beginning to the end. And part of the time we spent in cycle time was process time. So this is time when actual human beings were spent actually working, not waiting, but working. Wait time is when human beings spent waiting. So that's all I'm going to say. Those four right there, and I'm going to show you some pictures now. There's one more kind of time, and I described it earlier in the Henry Ford example. I said that Henry Ford took, by 1914, I said Henry Ford could make Model T in 90 minutes from beginning to end. And then he was dropping a new Model T, and they were driving off the line every 3 minutes. That 3-minute time frame is called takt time. Takt time comes from the Japanese takt rate, which basically is the beat or rhythm of the process. It's how many come off and how fast they come off. So, in our little example here on the slide, it says that there's going to be 60 customer orders, and we're going to have 6 hours to process those customer orders, or 360 minutes. Therefore, if we're going to have to process one customer order every 6 minutes in order to satisfy the customer demand. And if we're not able to do that, then we're going to have to increase the capacity of whatever it takes to process those orders. Either that or we're going to have fewer customer orders, which sounds to the business like a really bad idea. So we're going to have to improve the capacity in order to make that work. All right, so here's a picture of a value stream map. Now, of course, it looks like a process, and that's because that's what it is. So it's a process that has step 1, step 2, step 3 in this very simplistic picture. And then it has the total amount of time between the beginning of step 1 and the end of step 3 is called, that's how long the process takes. And then down at the bottom, we've got this little sawtooth diagram where it's got, it goes across and goes down, and then it goes across and goes up, down, up, down, up, down. On the top line, that's called process time, and that's the actual amount of time that we spend working on this process. Human beings are actually working for that amount of time on this process. And then down below that is wait time, and that's the amount of time that happens between steps on the process. So between steps of the process, that's the amount of time. Okay, all right, this is all very theoretical now. Let's get a little more specific. All right, so what if I could give you one number, a single number that stood alone, that by itself told you how efficient the process was. Simply how efficient the process was in one number. Kind of a how good is my process number. You would say, that's kind of cool. I like that one. So just one number. And we call that in Lean the operational process efficiency rating. It's expressed as a percentage. And it's how efficient is the process based on the process time versus wait time versus lead time. So let's go look at how that might happen. All right, so here's a little bigger process. In this case, it's a simplistic change management process or an order for a new system or whatever it might be. Okay, in this one we have 5 steps. And in those 5 steps, we have this little box on the bottom. And that's got what's called our standard working time. So that's how long we expect that step to take. Down here, at the top of the sawtooth, we've got what we call process time, which is how long the step actually took. So that's the actual amount of time that step took. And then down here, on the bottom line, we've got wait time and lead time. And lead time in this case is only 12 minutes before we actually started working on it, and there's no lead time at the other end. So, but everything in between these steps, this wait time is part of lead time. Remember, let me define lead time real easily. You want a car, and you'd like to order a brand new car, and it's custom. They don't have one on the lot, and you'd like it by August 1st. When do you need to order it? That's the lead time. Simple. If it's a 6-week lead time, I better order it by the 15th of July. If you'd like a new couch and you'd like it ready for the graduation party of your teenage son, then when do you need that new couch? When do you need to order it? That's the lead time. You want a wedding dress. This is the one that keeps coming up when I teach this class. If you want a wedding dress and you want it perfect and fitted and everything right, what's the lead time? When do you need to order the wedding dress in order to have it in time for the wedding? That's lead time. We're very familiar with lead time. So lead time is the exact same thing. If I want this change in my production environment by August 1st, when do I need to ask for the change? That's the lead time of getting that change in. So that's how long the change is probably going to take from the time I put it in as a request for change until it's actually in the production environment as lead time. Okay, so now you understand. There's standard waiting time up here. There's process time down here, actual time spent on the process. And there's lead time and wait time down here. So then we perform a calculation. We add up all of the numbers on this top level, 12, 15, 75, 205, and 45, which comes to 352. And then we add all the numbers on the bottom level, and we come up with a number, and we add the number that we came up with at the bottom to the number we came up with at the top, and that's lead time, which is the total amount of time it took from the beginning of asking for this change until the change went in. And that's called lead time. We take that lead time and we go over here to this fraction, and we put 352 as the numerator and 5284 as the denominator, and we do the math, and it's 6.6%. The process on the screen right now is 6.6% efficient. And in that 6.6% efficient, we have things like 8 hours worth of wait time here. We've got, looks like 4 days worth of wait time here, maybe 8 days worth of wait time there. We have a lot of wait time. We have a lot of time. And let me be clear, time is the key production element in IT. It's really what we have to deal with? Time. It's what we can offer. It's what we can improve. We can first go after quality, and the next thing we've got is time. The biggest complaint about IT is always going to be time-related. It's always time-related. We didn't do it quick enough. We didn't come out with it quick enough. It took too long. It took too long to answer the phone. It took too long to do this. It took too long to produce the change. It took too long for the project. You took too long to write the app. You took too long to release it. You took too long. Time. It's all we ever hear in the world of IT. All right. So since I have a bunch of bright people on here, and every one of you has a calculator, otherwise known as a smartphone, sitting right next to you right now, whether it's on the desk, in your purse, or in your pocket, take that calculator out right now, bring your calculator up, and I'm going to give you a test. I'm taking this and I'm pulling the numbers out. Before I do that, I want to make a point. Where did we get these numbers that showed us how long things actually took? We went down and watched. We watched the change happen. We followed a change through the process. So we just followed it through the process. And we followed how long people were actually working on it. And we followed how long it took to get to the next step. We followed the wait time. We actually followed the change. These numbers aren't going to be presented to you like I'm presenting to you on some nice little slide. These numbers you're going to have to go out and get this data. And that's actually the hardest part, is getting accurate data. Because what you need to do is get the data, then confirm that the data is accurate by asking the people who actually do it whether this is how long it actually takes. And when they validate the data, then you can come up with the number that we're about to come up with. So here we are. We don't have the answer down here. So we need the process time. So get your calculators out, and we need to add up all of the numbers at this level. So we need to do an addition. I need 45 plus 60 plus 19, 20 plus 205 plus 45. The answer to that is called process time. So that should be pretty simple. You're adding up 5 numbers. So now you have a number. And you take that number, that's called process time, and that's going to show up as the top of our fraction. Next, we need the next piece. We need to add all these bottom numbers up, which is how long it actually took between steps of the process. So how long it took, which is basically wait time. And so we're going to add up those 5 numbers, and that's going to be 12 plus 120 plus 480 plus 1440 plus 2880. And we're going to come up with an answer. Now, because we're looking for the total time between beginning to end, because that's what lead time is, we're going to add the number we just got, the answer to the bottom ones, to the top ones, the answer to the top ones, and we're going to come up with a number, and that represents the total time it took for this process from the very beginning to the very end. And that's called lead time. And if we do it right, we get this answer. We added up the top, and we came up with 2610. We added the bottom and the top together, and we came up with 7590. And then we did the calculation. And the calculation told us that this process was 34.4% efficient. Now, believe it or not, that's actually pretty good in the world of process. Should it be 100% efficient? Well, absolutely. There's no question. It should be 100% efficient. Get to work. But in reality, what we really are looking for is a way to measure it. And then once we measure it, if this is a real process in your organization, and you had this stuff that we have right in front of us now, this slide, you put it up on a whiteboard or a screen, and then you just presented that in a meeting, in a departmental meeting, that of the people who actually did this process, how long do you think it would be before anyone staring at this would go, wow, I think we could improve on that wait time. Yes, I think we could. Maybe it's because we have the meeting on Wednesday instead of Monday. Why do we have it on Wednesday? Well, we just always had it on Wednesday. Boy, it would cut the wait time down by 2 days if we had the meeting on Monday. Yeah, let's have the meeting on Monday. Okay, poof. So we start to get to the point where just showing data in this format can actually help improve, and the people doing the tasks are the ones who actually will come up with the ideas, will come up, first of all, with the desire to improve, because they don't want to wait between things. They just have to, because that's the way we do it, because it's policy enforced waste. So this is a wonderful exercise. It's just one tool, a value stream map, and the operational process efficiency rating is just one tool within the quiver of lean IT. But it's a great visual, and it's a great way for you to get pretty much instant feedback once you get the data, which is the hard part. But you can get instant feedback from the people actually doing the process, instant ideas on how we can make it better, how we can make it more efficient. I hope that that helps you a little bit in the world of lean, and I encourage you to ask me questions, either send me an email, you can tweet me, you can go to the chat panel that we've got right here, or the Q&A. I think the chat would be better. You can go to the chat panel, and you can ask me any questions live right now. We seem to have about 8 minutes left. If you have any specific questions, can you download the recorded presentation? Yes, I am recording this, and it will be available from the Pink Elephant website. Give us a day or so, and we'll get it up on the Pink Elephant website on one of those tabs, so that you'll be able to download the whole thing. Okay, let's see. Anybody else with any specific questions? Yes, I got a couple. Oh, you're welcome very much. Thank you. I'm glad you enjoyed it. Okay. All right. Okay. I think we're good to go, and hopefully we will. Please tune into any of our next Pink Elephant webinars. I thank you so much for coming. I appreciate your participation. I appreciate you listening. Thanks a lot. Bye-bye.